Section 7.2 has to do with capacity, weight, and temperature. Capacity is going to be the basic unit in the metric system, is going to be the liter. And weight, we have the gram. And a gram is about the weight of a paper clip when we're measuring things out. And most people are familiar with a 2-liter bottle, so obviously half of that would be 1 liter. And these are the basic units then. The section exercises for 7.2 start again with the normal units and just simply working with them. So as long as you have common units again, so if I have 35 ounces plus 72 ounces, as long as the units are the same, I'm just simply adding up for 107 ounces. Number 4, right below that, I have 210 liters. I'm subtracting 154 liters, and I would get 56 liters. So as long as they're the same, we're great. Number 7, again, we have those convertings, or conversions. So we're converting 34 cups to how many quarts? Okay, so first off, we have to go to our charts, and again, the book has some very good charts that I would strongly encourage you to look through. And so we have 4, which is the biggest one. Again, we like which is the biggest one. And so quarts is the larger unit, so we have 1 quart and the equal number of cups then. There is 4 cups in a quart. And then, of course, we would cross multiply and divide. So 1 times 34 divided by 4 is going to give us 8.5 quarts. Again, I would set those ratios up and then just cross multiply and divide. Number 8, right next to it, same type of a deal. We have 34,600 milliliters, and we're going to convert that to liters. Okay, liter is 1, so it's going to be the larger. Milliliters is over here, is smaller, so 1 liter. And it takes 1,000 milliliters to equal 1 liter. So again, our ratio is going to be 1,000 milliliters is equal to 1 liter. So we're cross multiplying and divide. So when we're dividing by a multiple of 10, in this case it's 1,000, we simply can move the decimal over. 1, 2, 3 spots, 1, 2, 3 spots, and we would have 34.6 liters. Again, the same things we've used before in the other chapters we can apply here. As we continue through this, objective 2 then is simply multiplying or dividing. We were adding or subtracting up above, now we're multiplying or dividing, where we would have, like in problem 22, we have 3 times 18 ounces. You're just multiplying, nothing weird, nothing fancy here. 54 ounces. As long as you have common units, you can add or subtract, multiply or divide. However, if we have to convert, such as in problem number 27, we have 8 kilograms is equal to the number of grams. In kilograms is way over here. It's the largest, so I'm going to put a 1 kilogram. And we have 1 spot, 2 spot, 3 spots. That's going to be 3 zeros, so it's 1,000 grams is equal to 1 kilogram. So we're cross multiplying and dividing, and then we would have 8,000 for our answer. 8 times 1,000 divided by 1 for 1,000 grams. Right? Last but not least, one of the objectives is to be able to use the temperature conversion. So the formula that I like the best is Fahrenheit is 9/5 Celsius plus 32 degrees. So when you have a problem, you can either plug it in for F or C and then do the math. So problem number 44 has 20 degrees Celsius to Fahrenheit. So we have 20 degrees Celsius, and we're going to convert that to what is it in Fahrenheit. So in our problem, we plug in our formula then. 20 is Celsius, so we're going to have 9/5 and 20, because we're plugging that in for C, plus 32. Well, again, whole numbers are going to go over 1. So we're going to reduce any number in the top with any number in the bottom. Well, 5 will go into 20. So that's 1, 4. 4 times 9 is 36 over 1. And we don't really need it over the 1 anymore because we really want the whole number. So we've solved that, plus the 32 we didn't do anything with, and that's going to equal our number in Fahrenheit. Now we can just add it together. Well, 36 and 32 gives us a total of 68 degrees. Okay, let's do one more of those. Let's do one where we have a Fahrenheit. So let's do 43. Let's just back up a problem. And we had 101 degrees Fahrenheit, and we want to know what that is in Celsius. Okay. Well, we've got to get C by itself because we're solving for Celsius. So that means we have to work backwards. Well, we always work with the side with the variable, just like we always have. So we're going to take away 32 from both sides. And again, I put my operation symbols in, just like I have done before. That cancels. So we left with there 72 degrees is equal to 9/5 C. Well, we want to clear out that fraction, don't we? Remember how we do that? That's right, we flip this. So we're going to flip this fraction. So we're going to multiply both sides by 5/9. Whole numbers go over 1. So cancel, cancel. I'm left with C. 9 does go into 72. 8 times. 9 goes into 9 once. So 5 times 8 is 40. 40 is over the 1. I don't need to put it over the 1 because we have our answer. So again, both of these are just similar to the algebraic problems we've done before where we're having a variable. You have to just decide, are you solving for the F or solving for the C, which is Fahrenheit and Celsius, and then working backwards. So it's very similar to section 1 with the conversion, setting it up, cross multiplying and divide, with the addition of the temperature formulas. Have fun!